Hey, geometry. All right, let's talk about equations of lines in the coordinate plane. This is nothing new, right? We spent a lot of time talking about this stuff in Algebra 1, so hopefully it'll all come rushing back, but if it doesn't, we'll get some practice in class, as well as during this video. So, slope, hopefully you remember, is just rise over run, right? We have rise over run. That's all that is, which means we go, say, from this point right here on the x-axis, we're going to rise, and then we're going to run to another point. And this gives us our slope. Notice it also gives us a triangle. This is going to be helpful to us when we get into some algebraic proofs of congruency in triangles and similarity in triangles. And it's also going to help us in trig next semester. So this, again, hopefully is review. So rise over run. Another way to say that, or the slope formula, is, very strictly speaking, oh, hey, y2 minus y1 over x2 minus x1. So you're going to take the y coordinate from, let's call this point 2, and subtract the y coordinate from, let's call this point 1. So let's do that. What is the y coordinate here? Let's just count, yeah? So the coordinates of this point, point 2, are 1, 2, 3, 1, 2, and the coordinates of the point on the x-axis are just 2, 0. So calculating the slope, we get our y2 is going to be this value, which is 2, and then we subtract y1, which is down here, is 0. And then we do the same thing for x. x2 is this guy, that's 3, right? It's the x coordinate of the second point, and we subtract the x coordinate from the first point, which is 2, and we get 2 over 1, so that's our slope. Slope equals 2. Now we could also just count squares, right? Probably remember doing this. We could just say, all right, here's point 1. How many squares up do I go? 1, 2. How many over? 1. 2 over 1 is 2. That's perfectly legitimate. Some graphs, though, are pretty funky, and it's hard to count the squares. But usually not. If you can make out the points, you can probably count the squares. Okay, so we do have positive slope, negative slope, and as you notice, positive slope is just going up, right? We're going up, 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 as we read the graph from left to right. We read the graph in that direction, and whatever direction the line is taking as we read the graph left to right tells us positive or negative slope. As you notice down here, as we read left to right, the y values are getting lower and lower. This line is descending, right? It's pretty intuitive. That part's not so hard. Let's do an example. In this case, we have, what do we have? We have 2 points. And we can either graph them and count squares, or we can just use the slope formula. I like the slope formula. Notice, again, though, it's very important that we name our points. We decide which point is going to be point 1 and which point is going to be point 2. And be consistent. And I always actually like to write them. Now, it doesn't matter which point is point 1 and which point is point 2, as long as you are consistently taking your coordinates from the right points. So let's call this point 2. I want my y coordinate from point 2, which is 4, minus my y coordinate from point 1, which is 3, over my x-coordinate of 0.2, which is negative 11, minus my x-coordinate of 0.1, which is negative 8. Notice we have a minus negative 8. So up top we get 1. On the bottom we get negative 11 plus 8 is negative 3, so we get a slope of negative 1/3. Let's do another one. Oh. M equals y2 minus y1. We're going to write that every time. And again, I'm going to name my points left to right. I like to be consistent. Saves me a lot of trouble. So my y-coordinate for, or my y2 is my y-coordinate for 0.2, which is 2, minus 2. Right? That's the y-coordinate for 0.1. My x-coordinate for 0.2 is negative 6, minus 3. And I get 0 over negative 9. What does that look like exactly? Negative 9, 0 divided by anything is 0, right? So what does a 0 slope look like? Well, it looks like that. And you get an equation for that. Whoops, sorry about that. You get an equation for a line that has 0 slope is going to be y equals something, some constant. And in this case, we're going to say, y equals, what do you think? 1.5? The coordinates kind of in the middle there. So the other slope we haven't talked about is, remember this guy? Remember this is? Anybody at all? Well, let's figure it out. M equals, if I call this 0.1, call this 0.2, I get y2 minus y1, x2 minus x1, and I get up top negative 6 minus 9, and 5 minus 5 on the bottom. I get m equals negative 15 over 0. And we cannot divide by 0, can we? So this slope is undefined. And I would take the trouble to actually memorize these graphs. All right. Remember slope-intercept form or point-slope form of equations? We'll do a couple of these and then we'll leave the rest for in-class work. But we have slope-intercept equation where this guy is your y-intercept and that's your slope, what we've just spent time figuring. And then point slope. This is useful if for graphing, right? The slope intercept is useful for graphing. Point slope is useful if you have a graph creating an equation, or if you're given 2 points, creating that equation. So this is just y minus y1 equals m. What is happening even? M times quantity x minus x1. So let's do a couple of examples and hopefully it'll all come back. So if you have, you're given, in this example, the slope is 2/3, and it passes through this point. How can we write a linear equation? Well, we already know m equals 2/3, right? So we have m in both slope-intercept form up here and in point-slope form here. So that doesn't help us narrow it down, but what does help us narrow it down, which form we want to use, is the fact that we're not given a y-intercept, but we are given a point. So we're going to use point slope form. And we're going to say y minus this y coordinate we're given, which is minus 6, so y minus negative 6 equals 2/3 times quantity x minus, again we have a negative, x minus negative 2. And we end up with y plus 6 equals 2/3 plus, oh no, plus 4/3. And suddenly I can't see a thing. Now what if we wanted to write that in slope-intercept form? We could do that, right? With what we have right here, all we would have to do is rewrite this solving for y. Let's do another example. Last one, best one. In this case, we're not given either the slope or the y-intercept, but we are given 2 points, and we can use the point slope form to write an equation. So let's do that. First thing we're going to have to do though is find the slope. M equals, I'm going to call this point 1, call that point 2, 8 minus 5, 5 minus 0 gives me 3/5, right? Now I can use either one of these points and plug in the x and y coordinates into this point slope form of the equation to get our linear equation. It doesn't matter which one, as long as you choose your coordinates from the same point. So you got to choose your x coordinate and your y coordinate from the same point. So now we have y minus, I'm going to use point 1, y minus 5 equals 3/5 is my slope, that's my m, times x minus 0. Y minus 5 equals 3/5 x. Now if I wanted to change this into slope-intercept form, all I would have to do is add 5 to both sides, and I would get y equals 3/5 x plus 5. So my y-intercept is at 0, 5, and that's my slope. And that's all there is to that. Again, we will get a lot more practice in class. Talk to you soon.